So the first question is number 19. Number 19. There's an object which is thrown horizontally from the height of h with an initial speed of v0, but actually this v0 is equal to v0x, because this is horizontal velocity and it will be constant. Okay, it will be constant. So when it strikes the ground, it's making a velocity of 100 meters per second with an angle of 37 degrees with the horizontal axis, and find the ratio of x and the height, x over height. So it's very simple question. In physics, we need to start with the given information. The given information is this value. So if we can show Vx and Vy, okay, and then we can find out Vx and Vy first, because to get h and x, first we need to calculate the time taken from this point to that point. So that's why this will help us to figure out the time. So what's the x value? Vx is equal to, yes, v times yes, cosine 37. So Vx is equal to 100 times cosine 37 is 0.8, and Vx becomes 80 meters per second. And this V0 is also 80 meters per second, because as you know that horizontal speed is constant, it doesn't change. So what about Vy? Because especially Vy will help us to find out the time taken. Vy is equal to V times sine 37, and Vy is equal to 100 times 0.6, and then Vy will be 60 meters per second. And if you remember that, if we are talking about the halfway of the projectile motion, to get the time, we were using this value. Vy is equal to g times t. Remember that. On Saturday or Sunday, I talked to you about that. So Vy is 60. So 60 is equal to g is 10 times t. The time taken will be 6 seconds. Okay, from this point to that point, it takes 6 seconds. 6 seconds. Now, again, let me remind you another thing. If we are talking about the half motion of the projectile motion, halfway of the projectile motion, the h formula can be used as it is, if you remember that. H was equal to half times g times t square. So we can get h 1.1 over 2 times g is 10 times time is 6 square. From here we can get h. When you multiply them, the answer will be 180 meters. Okay, 180 meters. The question was the rate of x and h. We already found it h. What about x, range? This x value. X formula was V0 x times t, as you know, and then x is equal to V0 x. What is this? V0 x is here, say 80 meters per second. 80 times 80 times 6, and then is equal to 480 meters. So the answer is h over x. You need to divide them. 180. No, it's x over h, right? X over h, sorry. Okay, this is wrong. X over h is equal to 480 over 180. And when you do simplification, so your answer will be 8 over 3. Okay. I'm passing another question from your breakdown questions. Question number 22. An object is thrown from the ground with an initial velocity of v0. We don't know v0 at an angle of 53 degrees. And if it's minimum, okay, Mr. Talgat, someone is attacking to the screen. Mr. Talgat?
Can you disable from the shading options?
No, last time two students did this. I'm warning them from here, okay? We don't have time. Please, let's concentrate the questions. Just listen. Okay, an object is thrown from the ground and we don't know V0, but if its minimum velocity is 30 meters per second, what is the range? This is the question. This is the question. So what you need to understand, what is the meaning of if its minimum velocity is 30 meters per second? Okay, except the point where the H maximum is, okay, the other points from the left side or right side, the velocity has X component and Y component. Y component and X component. Okay, but only there is one point at the point of the H maximum. There is only one horizontal speed, which is V0x. And then if its maximum velocity is 30 meters per second, means V0x is 30 meters per second. This is a trick question. We are getting, we are understanding that it's talking, they are talking, the question is talking about 30 meters per second, which is V0x. Now we can find the x. How? First, we need to get Vy and Vx again. We already understood that Vx is equal to 30 meters per second because, as you know, it doesn't change. What about Vy? But first, we need to get V0 itself. Okay, what is the relationship between Vx and V0? Let's write it down. V0x is equal to V0 times cosine 53. Cosine 53. So V0x, we know 30 is equal to V0, and the cosine 53 is 0.6. And then when you get V0, which is 50 meters per second. By using another formula, we can get V0y. V0y is equal to, what is V0y? V0 times sine 53. V0 times sine 53. Okay, 53. So V0y is equal to, this is 50, we found it already, and 0.8, and V0y is equal to 40 meters per second. And everybody can understand that if you can take the half, okay, if we can consider the halfway of the projectile motion, we are allowed to use V0y is equal to G times T formula for the vertical motion of the projectile motion. So V0y is 40. I think you understood that if you see the V0y, it will take 4 seconds to go up to the H maximum, and then there will be another 4 seconds to go down. But we need to prove that. I'm showing you 40 is equal to 10 times T, and T will be 4 seconds. What is this? This is the time taken. Let's say this is point A. Let's say this is H maximum point B. And then let's say this is point C. This is the time taken from A to B. But to get X, we need to consider whole motion. So if the time taken, okay, let's say T1 is 4 seconds. And then T flight, okay, total time flight is equal to 2 times T1, because if it is take 4 seconds here, another 4 seconds here, so totally 8 seconds. Now we know that total time flight is 8 seconds, and then we can write the formula of the X. X was equal to Vx or V0x anyway, times T flight. In the first question, we used the same time, like this. We used the same time, 6 seconds here to get this, because in this question, there was only halfway, okay, of the projectile motion. Just we consider this from here to here. But now in the second question, as you can see here, we found it 4 seconds from A to B. For the whole motion, it's going to be 8 seconds. So this is the formula. X is equal to, what is Vx? Vx is given 30, right? Which is given initially 30. So 30 times T flight is 8 seconds, and your answer will be 240 meters. I hope you understand that. We can go to another question. You can mark it, the answer of the question number 22 is 240. But anyway, on Friday, guys, on Friday, I will share another link, the same for the same breakdown, but with their answers. And then you will have a chance to check the answers, okay? Another question is 30. So two objects are thrown horizontally with an initial speed of v1, v2 from the different heights as shown in the figure. Find the ratio of the velocities v1 and v2. Okay, one object is thrown horizontally from the height of h, and the second object is thrown horizontally from the from the height of 4h. So they are thrown initially, and then they are coming to the same point, which means their range are same. We will use this property to solve the problem, because the question is v1 over v2. In this question, there is no number, only we will work with the letters, okay? So our answers will be in terms of h, something like that. So my question is, just consider for the first one, if I ask you what is the h formula for v1 for the first, let's say this is a, let's say this is b. So for a, the height is h, right? The height is h is equal to half times g times t square, t1 square, because the time taken will be different, right? So what will be, okay, h will be equal to 8g is 10. It's going to be 5t1 square. We can keep it as it is here. For b, What is the formula? Same formula, but what is the height in terms of h? This is 4h, right? 4h, the height is 4h is equal to half times g times t2 square. So, so if we can leave it h in one side of the equation, so 4h is equal to 5 times t2 square, right? But anyway, we can leave it as it is. Later on, we can do another action. Right now, by using the formula of height, we can get this information. So the second thing, what is the same for their what is the same for A and B? Their range A and range B is they are equal to each other. So what's the formula for AX for the range? Isn't that horizontal speed times time? So let's apply this rule for both. For A, we can say that's okay. V1 times the time taken is here, right? So if we can get it the time t1, if you can see that this is in the root h over 5. If you isolate t1 in one side of the equation, from here we can get t1 as in the root h over 5. Here it's going to be t2 will be in the root 4h over 5. Okay, you can isolate t1 and t2 like this. So what is t1? Let's write it down. T1 is equal to V2 times T2. So what's the question? Question is V1 over V2. What will be V1 over V2 will be equal to actually T2 over T1. Okay. And what is T2? T2 is equal to in the root 4h over 5 over in the root h over 5. Okay, and the rest of it is our math skills. V1 over V2 is equal to, we can, I can show you something like that. So they have same roots. In the same roots, I can show you like this, 4h over 5 times, I can make it upside down, 5 over h, okay, h, and then this 5 and this 5 will cancel, and h and h, and the answer will be root 4. Root 4 is equal to 2, okay? The answer is 2. All right. Next question. I would like to solve this question on Saturday. It will take a little bit time. We have no time in this session. Okay. We can solve this question on Saturday. I would like to pass another question. For example, this. Let's solve this question. What is the force applied by the wall on the left? Okay. On Saturday or Sunday, we solved similar question to that, but the shape is different right now. First of all, I need to say that in this type of questions, when you show the weight, okay, weight of the object, if this angle is 37, be sure that this is also 37 degrees. Okay, this is a practical way for you. Okay, and geometrically you can prove that, but I'm telling you guys in this question, this is 37. This is also 37. Anyway, there are two walls here. There are two walls, and then each wall will apply a reaction force to that. The first one is this force, let's say F1, okay, and another force is this F2. Okay, it is in this object is in equilibrium, and then we need to consider how many forces acting on this object. I'm seeing that there is only 3 forces here. One is weight, the other one is F2 from this wall. Let's say this is the first wall. This is the second wall, and the weight is given as 120. To solve this problem, what I told you, we need to draw the free body diagram to understand the relationship between them, because if the question is related to equilibrium, you need to remember two things: first condition and second condition. If the question is related to first condition is total F is equal to 0. If this system is in equilibrium, it means that total Fx is equal to 0 and total Fy is equal to 0. This is the first condition. Okay, first condition. Second condition is related to total torque is equal to 0. But this question is related to first condition of the equilibrium. So if we can draw the free body diagram and the direction, and then we can choose these points as the center of the system, and then we can show the forces. F1 is to the right. F1 is to the right, and this is F2. This is F2. The direction is up there, and the other one is. But what I'm doing is for F2, I'm just carrying out this in the same direction like this, right? So which means when I show the weight of the object, if I can extend, okay, if I can extend this line, and then from here, you need to understand that this angle is 37. Okay, this angle is 37. So if we can extend the line of the weight from here, and from the geometric skills, we know that this angle is 37, and also this angle is 37, because we need that angle. Why? Because we are going to use first condition around this point. We see that this is 120 newtons down. F1 we don't know, and the question is F1, by the way. The question is what is the force applied by the wall on the left? Okay, so the question is F1. But if you see that there are three forces, and this F2 has two components. So let's say this is F2x, and this is F2y. I'm gonna speed up now. Quickly, I can say that this weight will be equal to F2y as a magnitude, and this F2x will be equal to F1. What we know W, right? The weight of the object, and then we will equalize to F2y, and then we will jump from F2y to F2x. After finding F2x, we will say that okay, it's going to be equal to F1 as the magnitude. So that's why let's start with the y. Total Fy is equal to 0, and then F2y is equal to W, right, on the y-axis. What is F2y in terms of F2? Yes, this is F2 times, yes, angle is here, and then it's close to F2y. We will say that cosine 37. F2 times cosine 37 gives us F2y here, and then W is 120, and then from here F2 becomes let me see, 120 over 0.8, and this is 150 newtons. What is this? This is F2, the reaction force from the second wall. But the question is F1. To jump to F1, we need to find out F2x. Okay, what is F2x then? F2x is equal to F times sine 37. If you see that from the figure, sine 37. Be careful, I'm using this angle. According to that, this is sine 37. So F2x is equal to F is no F2, sorry, F2 is 150 times 0 is sine 37 is 0.6, and then when we multiply 150 by 0.6, F2x will be 90 newtons. Then I'm finishing because total Fx is equal to 0 in the system, which means remember that F2x is equal to F1. F1 is equal to F2x, and F1 is equal to 90 newtons. Okay. Okay. I hope you understand that. And Mr. Talgat, how many minutes we have? I will range my time.
Last 10 minutes.
Last 10 minutes. Okay. I think, okay, we did great. We can solve this question. Okay. And this question is related to equilibrium, but for the second condition, what is the tension in the rope? The rod is weightless. We will not consider in the middle of the rod like there is a weight. There is no weight because we ignore the weight. And this point is pivot, and then the system will turn around this point. According to this information, only we are seeing that there are two forces. One is tension force on the rope, and the second one is the weight of this object. And then what we need to do for the second, what was the second condition? Torque is equal to 0. What torque? Total torque is equal to 0. And this sides, let's take positive. This turn, let's take as negative. And then according to the effect of the force, it's better to indicate that their sign. This rope, this tension force is trying to balance the system in this direction, right? So when we are using the formula, we will use the T as positive. But this weight is trying to turn the system to that side, and then which means it is negative. When we use the formula, we will use the weight as negative. Okay, so our formula is total torque is equal to 0. And then let's write down the let's use the total formula. What was the total formula? Let me remind you. The product of the force and distance if force and distance are perpendicular to each other. Here, this is the first distance, and look at this. This is the first distance, distance 1. Let's say distance 1, and this is the distance 2. And then these are the forces. They are perpendicular, and this is another force perpendicular. So that's why there is no problem with that. Directly we can multiply force by distances. So let's use that. First, T times T is positive. T times what is its distance? 40 centimeters. 40 plus. What's the second force? This is the weight of the object, but it is going to be taken as negative. Negative 80. Negative 80 times what is its distance? Not 140. You need to take all the distance. This part is 40. This part is 140. Totally distance 2 is 180 centimeters, right? And then 180 centimeters is equal to 0. Then this part is negative, and then we can take it to the other side to make it positive. T times 40, T times 40 is equal to positive 80 times 180, right? To get T, we can divide both sides by 40, and then T becomes, this is 1, this is 2, right? And 2 times 180, this is 360 newtons is your answer. Okay, guys. Today is enough because the questions that I got from the Noria, they were these questions. We don't have time because it's taking a bit time. That's why I just refer to another session. So time will not be okay. So that's why let's solve this question later on. Again, for those who came late to the lesson, on Friday I will share the new link, okay, of the breakdowns with their answers, and then you can check your answers, what is true, what is not. Even when you do this, when you solve these questions, please send it to me. Okay, when you finish, you can send it directly. It will come to me, and then I will check how is the situation, and I will understand that for which questions you are stuck in generally. Okay, it will give me a sign to solve the problem, and my plan is to give you extra lesson on Saturday, one more, the last one before the exam. I think we can close the physics parts like this. Okay, thank you very much for coming, for participating. I didn't finish evaluate your homeworks 3 and 4, and probably on Friday I will finish all of them, and then you can see the results. Okay, thank you very much. Mr. Talgat, thank you.
Sir, they are asking, can you show 49 again?
49.
Yes, and Dennis has questions.
49. This one?
I think yes.
They will take a note.